Okay, you did the vertical asymptotes yesterday. We're going to start off with horizontal asymptotes. The way, remember doing this, we had our f prime, or f and f prime. F of x equals, let's say, x plus 2. F prime of x is the inverse function of that. You remember doing that? When we took, what we did is we took this and we made f of x equal to y, x plus 2, and then we switched these two around. And we said x equals y plus 2, and then we solved for y equals x minus 2, and that would be your x minus 2 would be your inverse function to it. All right? Remember doing that. Now we're going to take a look. If f of x equals, let's say, x over x plus 2. Now let's make it easier. Let's just make this a whole number up here and call this 3 over x plus 2. Okay? And we want to solve this. We want to find the f prime of x. This is going to give you your y, or your horizontal asymptote. All right? So if we solve this, we call this y, 3 over x plus 2. Switch these around, x equals 3 over y plus 2, and we start solving this. We can bring y plus 2 up here, bring x down below over here, so we just switch them around, and then we subtract by 2. This is your horizontal asymptote. When you look at this equation, that would be your f prime of x. This would be f prime of x up here. 3 over x minus 2. So, can x ever equal 0? No. So what can you approach but you not hit? It's where your y is negative 2. You can approach that, but you can never hit it. Well, in this case here, x can't equal 0, right? So we can't ever get 0 out in front of this. So if we were to graph this, what you're going to do is you're going to have negative 2, 1, 2. You're going to have, let me just draw this across here. You're going to have something that's going to approach this. Let's see, how would that come? It'd probably come like this. It would approach it, but it would never, ever hit it. So the asymptote, the horizontal asymptote in this case, is your negative 2. All right? We're never going to hit 0, and we're never going to hit negative 2. For the x, never 0. For the y, never negative 2. So that's your horizontal asymptote. All right, see how we figured that out? Got the inverse and worked from there. All right, good. Any questions on that? How we do it? All right. The slope asymptote. This one's a little bit more difficult. Let me use an example they're using right out of the book. F of x is x squared minus 2x plus 1. F of x equals x squared plus 2, or minus 2x, I think, plus 1. I believe that's minus. Divided by x. Okay? Here's what you have to do. You have to divide x into this. You have to divide x into it. And you're going to come up with, do you guys ever remember doing your division this way? Your coefficients out in front? You can do it, actually, you want to know what I'm going to do? I'm going to do it this way here instead. I'm going to do it like this, because I do like doing it better this way. x squared minus 2x plus 1 in here. What's my value? I'm going to multiply this by x to get x squared, right? And now I can multiply this through. I get my x squared. Subtract this 2, I come up with a minus 2x plus 1. I subtract this by a minus 2. I get a minus 2x. And I'm ending up with a plus 1 down here. So when I divide this through, f of x actually equals x minus 2 plus 1 over x. And you graph it. X minus 2, 1 over x. They put 1, no, they have it as 1 over x. Yeah. If you graph this, it would be, you'd actually be graphing this. But here's where your asymptote's going to be. Your x, we can't work with this part of it, correct? This is going to give us our slopes like this, if we were to work here. But this they're calling g of x. What's sitting out in front of it would be x minus 2. That there would be your slope or your slanted asymptote. X minus 2. That first portion. The reason why is, right here, we can't get this to 0, can we? Right? We can't make this 0, so this will never be able to approach x minus 2. Right? I want to see if getting this 0, I can't get the 0 here, so we'll never be able to hit x minus 2, whatever that graphs out to being. Let me redo my graph here. Yes? What are you talking about? Oh, negative 1 here? So I'm subtracting, right? This would be 0. No, a minus 2 minus a minus 2. What's that? Well, yeah, I'm subtracting these. Okay. Am I doing something wrong here? Or I got it right, don't I? All right. All right. I'm assuming that you're subtracting when you divide like this. So this becomes a plus. This becomes 0. Okay. So not what I wanted to do. I didn't want to do that. All right. We had x, minus 2 plus 1 over x. All right. If we put in f of 0 in here, this becomes an undefined function, doesn't it? So we can't ever get this to 0. So what do we have left is our x minus 2. This is the portion right here we'll never be able to reach. So if we were going to graph this, let's just call it y equals x minus 2. If I put 0 in here, I'd be down 2. If I put 1 in here, I'd be negative 1. So I'd be like this. This would be an asymptote to this equation, which means I'll never be able to hit this point. That's called a slanted asymptote. And the way I did that is by taking this original equation of x squared minus 2x plus 1 divided by x and actually dividing this out. I was able to find what the sloped asymptote was, or the slanted asymptote was, by dividing this out, because we know that this portion of it will never equal 0. So if that can never equal 0, then we could never hit that portion of it. Does that make sense? Does that make sense? Sarah, do you see what I'm doing? If I put 0 in for this, I could never hit because this is undefined here. So wherever this is undefined, we take the rest of it because we know we can't use 0, and then this would make your slanted asymptote. Am I losing, guys? Got it? Kaylee, you understand what I'm doing? Do you? Okay. All right. Let's go back over. Let's see. I want to grab some. I want you. Did you do 15 through 18? All right. Go ahead and do those again, 15 through 18. And those are the only ones I want you to do, 15 through 18. And now I want you to find every vertical, horizontal, and slanted asymptote. Okay, all 3 of them, yes.
That's for slanted asymptote. It only occur when the degree numerator is exactly
one greater than the denominator.
Yeah.
So yeah, and doesn't that make sense?
The only one that can do it is
7. No, I want you to do all of them. Well, if you can't get a sloped asymptote or a slanted asymptote out of it, you can't get one. That's the only one you're going to get out of it. Okay, 17 will be the only one. So,